Good morning. This is the first session of August for DBA Fundamentals. Today we have Bob Ward and Anna Hoffman from Microsoft. They'll be presenting SQL Server to Azure SQL performance and availability. And as you know, you're always going to get a lot of good information from Bob and Anna. Our sponsor is DB Watch Database Controls. They're a company that has a product that I had somebody, I'm sorry, somebody came in and interrupted. A company that has a product that manages entire platforms, multiple types of systems. So it's not just Microsoft SQL, but that's obviously one of their big ones. Otherwise, they wouldn't be sponsoring us. Please go check out their website. That helps us as a virtual group, and check out their articles and try a free download. Past Summit this year is virtual with COVID-19, obviously, and we just wanted you to be aware of that. We need to support PASS as much as possible this year because they get a lot of their money from the in-person PASS. And it's a great organization and has been great for our industry in keeping everybody abreast of free education. There's tons of free education all during the year, but sign up if you can, because as one of the presenters was saying earlier, it's going to be very easy traveling to this virtual summit. So you will lose the availability of actually getting to see your friends, but this is hopeful for just 1 year at the most. If you do sign up, we have a discount code that will save you $50 off of the 3-day registration. Even if you do not use the 3-day registration, go ahead and use our code because we'll get credit for it. And you'll also be entered, if you use our code in any form or fashion, you'll be entered in a drawing for a $500 Visa card in September. We won these funds last year from the same type of contest, and we did really well. So if you want to have the possibility of that, would almost pay for PASS this year if you won that. So be sure and register for that. Remember our discount code. Today we have Bob Ward and Anna Hoffman, and they will be presenting about Azure SQL and the performance and availability, which is very detailed. As you know, this is going to be our future. We need to understand this. This should be a great presentation. And I'm sorry, I'm not doing a great presentation. But anyway, you don't care whether I do or not. You care whether Bob and Anna do. So I'm going to turn it over to Anna, and let's see. Let you start.
Thanks, Steve. As we get these things switched, the one thing I'll say about Past Summit is if you like what Bob and I do today, we're actually doing a full pre-con at Past Summit on sort of the same thing, but with more information. So definitely, if you're considering doing a pre-con at Past Summit, we would love to have you in ours. But with that being said, hopefully everyone can see my screen. My name is Anna Hoffman. I'm a data and applied scientist / PM on the Azure SQL team. And today I'm joined by Bob Ward.
Anna, thank you. And Steve and everybody in the virtual group here, thank you. You know, I was telling Anna about this group. I've been doing this virtual user group for like the last 4 years before everybody went virtual. So we were already doing the virtual thing with this group, right, long before everybody else was. And one of the things I told Anna about coming today was the fact that everybody in this virtual group is a SQL Server person and used SQL Server for years and love this product, love everything about it. And we thought it would be interesting for you to learn more from us about how to change and apply those skills to Azure SQL. And if you think about areas, Anna, about SQL Server, as we've talked about, to the core areas of performance and availability. So I think if you'll sit back and listen to what we have to say, we have some demonstrations for you. I know you're going to have some questions. So what we'd like to do, put your questions in the window with the GoToMeeting system. And at the very end, we'll leave some opportunity for questions there and let the moderators kind of feed us what things you have. But very excited to be with Anna today. We've been partnering on this topic for a while now. And so I'm going to let her kind of take it off and start digging into what to use when and understanding Azure SQL and about availability. And then I'll finish us off with performance.
Awesome. Thanks, Bob. Yep. So we are going to start with kind of some level setting, and this might be a review for many of you, but for those of you that this is new, we want to make sure we kind of demystify what Azure SQL is, because typically, and in the past, and mostly at fault of Microsoft, we've been a little confusing about the different options we have and what to use when. But I just like to start with this so that we all feel like, oh, these options are really great, as opposed to, oh, these options are very confusing. And we'll dive into other options throughout this session. But Azure SQL is a rebranding exercise we went through in May to basically say anything that falls under the Azure umbrella and SQL related, based on the SQL Server engine, that is, we're going to roll up into Azure SQL. So just to kind of give a brief overview of these options, the first is SQL Server on an Azure virtual machine. This is known as IaaS, or Infrastructure as a Service, and the way you can think of this is that we, being Microsoft, manage the host and the infrastructure and the hardware, but you are responsible for the OS and the SQL Server, which means upgrading and maintaining both of those things. But what it also means is that you have access and control to both of those things. We see this a lot with customers who have third-party software that needs access to the OS or need to run a very specific version of SQL Server. So that's IaaS. Now, if we abstract one level higher from that and say, I don't want to manage the host, the infrastructure, or the hardware, but I also don't want to manage the OS, then you get to what's known as a platform as a service, or PaaS offering, and that's Azure SQL Managed Instance. And this is basically where you get a managed SQL Server. So you get kind of what Bob and I always say is you get the best of SQL Server and the best of having a platform as a service offering. So this is going to mean you have to instance scoped features like Service Broker and SQL Agent, for example. Now, if we abstract one level higher than that and say, I don't even want to manage a SQL Server, I just want a database and to get going and building new modern intelligent applications. Well, that's where Azure SQL Database comes in, and this was the first offering that we had. So there's a lot of capabilities and options in here. Two of those, which you've probably heard a lot about, are serverless, which allows you to kind of pay more for what you use and kind of auto pause and not pay when you're not using it, as well as hyperscale, which is going to allow you to basically get unlimited storage, at least up to 100 terabytes today. And both of these options on the right, Azure SQL MI as well as Azure SQL Database, are platform as a service, which one of the big things here is that it's versionless. So you never have to go through an upgrade cycle again. So with that being said, we're going to take a dive and look at some of the availability capabilities in Azure SQL. Specifically, we'll look at database and managed instance today. So we're going to talk about some of these capabilities, and then we're going to kind of shift gears and talk about the tasks. And this is the same thing that we're going to do for performance. So it kind of gives you an idea, okay, as a DBA or data professional, what are the capabilities that Azure SQL brings to the table? How is it similar to SQL Server? And how do I need to just kind of change my thinking or consider a few things to get more out of the Azure SQL offerings? So with that being said, I'm going to jump right into backup and restore. This is a question we get a lot. Where are my backups? What happens? What do you mean automated backup? So just to break it down for you all, we do a full database backup once a week, log backups every 5 to 10 minutes, differential backups every 12 hours. And you can actually configure how long you want these backups to be retained, depending on the service tier, up to 35 days. If you need something more than 35 days, we also have long-term retention available, which can allow you to store up to 10 years of backups. And one of the wonderful things about this is that you can even, if you have long-term retention enabled, you can even restore backups of deleted databases. Now let's talk a little bit about these backup files. They're stored in Azure Storage with RAGRS, which means it's globally replicated storage. So regardless of the service tier, what this means is your backup files are automatically globally replicated, meaning that if for whatever reason a whole region goes down, let's say your database is in ECUS and the whole region goes down, you can still do a geo restore of your database in another region because your backup files are automatically, GRS replicated. So this is a huge win right off the bat without any configuration. We also have support for point-in-time restore. One thing that might be different from what you did in SQL Server is that you can't restore on top of the same database. You have to restore to a new database, basically with a different name, and then you can do all your checks. And then once you're ready, you can, either change the name and delete the old one or figure out how to go forward from that. That's just a little bit about backup restore. We're going to point you to a lot of resources at the end so you can go deeper in this. We even have free hands-on labs that are launching soon that can actually allow you to go through a point-in-time restore sort of hands-on lab. Now what we're going to do is we're going to shift a little bit and talk about the different service tiers and the availability architectures behind the scenes. Now the first one is general purpose. And something to remember is that this is going to behave similar to a failover cluster instance, which I'm sure you're all familiar with. But basically what we have on the right-hand side is we have some gateways and a control ring. We have our application, we have our primary replica. Now, depending on how you configure connectivity, you might go to the gateway every time, or you might go to the gateway first and then straight to the primary replica. But either way, you're just going to connect to the server or the logical server or the instance, and we're going to take care of that redirection for you. You're not going to have to manage all of that, especially in the case of a failover. Now, on the primary replica, you have your TempDB running on directly attached SSD. Your data and log files are stored in Azure Premium Storage, and that's LRS, so that's locally redundant or replicated storage. And your backup files, like I mentioned, are stored in Azure Standard Storage. Now, you might be wondering, okay, what happens if a failover needs to occur? Now, all of these things, all these database services run on the Azure Service Fabric. Basically holds everything together and monitors what's going on. Now, if the Service Fabric decides, hey, we need to fail over, what it's going to do is behave similar to a failover cluster instance. We're going to look for a node with spare capacity, then we're going to fail you over, and that recovery time is going to depend on the spare capacity available. Like I mentioned earlier, because of the way we set everything up, the connectivity and the redirection after this failover occurs is going to be built in. So that's pretty cool. You kind of get this right off the bat. Notice you don't have to set up anything. You just get this architecture with general purpose. Now with business critical, we kind of took it one step further. And now this is based on an always on availability group, which I'm sure a lot of you are familiar with, probably all of you are familiar with. But basically what you see here at the beginning is it's very similar to general purpose, except on the primary replica, along with TempDB, we also have the data and log files right there. And now because an always on availability group is running behind the scene, you're going to have 3 secondary replicas at any given time. And one of those replicas we're going to allow you to leverage as a read-only endpoint. Now, similar to general purpose and all service tiers, your backup files will also be stored in Azure Standard Storage. Now, one thing to consider here is that at least one of these secondaries must sync for a commit. Now, unlike the general purpose tier, when a failover occurs, it can happen much faster because we already have a secondary replica basically ready to go. So we can simply take care of the connectivity redirection that we already have and basically name this secondary a primary and then spin up another secondary, and you can be back and running without having to, have a lot of downtime or do the connectivity redirection, because we're going to take care of that for you. So just by deploying a general purpose or a business critical database, you're getting a lot out of the gate. And I want to show you some of these capabilities in a quick demo. This is a demo that I sometimes call dueling O-stress, if you've seen the O-stress tool before, or just the power of PaaS, so kind of what you get right off the bat. So if you just bear with me for a moment as I make sure we're all set up, then I will show you what all of these windows are. So hopefully we don't have a dead notebook there. But once this loads, what I'm going to do is explain what's happening. So on the left side, we have general purpose. So just remember, everything on the left side is general purpose. Everything on the right side is business critical. And I think my notebook might have died, so just give me 1 second and I will bring it back up. And up here on the right, what I'm using is Azure Data Studio. Specifically, I'm using PowerShell notebooks. I'm not sure if you all have seen these before, but I've become a huge fan of not only Azure PowerShell, but also PowerShell notebooks, because you can save your results. Now, let's see if this will behave for me. Nope, not behaving. Okay, give me one more try and then I'll call it. Of course it works, and then it doesn't when you do it live. But what we're going to do is we're going to use O-stress to basically force a failover and observe the results in O-stress. So we're going to basically query repeatedly and see what happens when a failover occurs with a business critical versus a general purpose database. It looks like we're in good shape here. So thank you for your patience. So while that's running, I'm going to kick off the bottom. So what you're going to see in the bottom left is I'm connecting to a general purpose database and doing a quick query, simple query to return a count in a general purpose database. And it's basically doing this 50,000 times. I'm doing the same thing over on the right-hand side, but this time it's in a business critical database. So we'll see, it's just returning the results, and this is supposed to illustrate application with retry logic, which is very important when you move to Azure for many reasons, and this is just one of them. Now what I'm going to do is I'm going to initiate a failover, invoke a failover on both databases. So again, remember, business critical on the right, general purpose on the left, and just observe what happens. So these are happening at the same time. So what we would expect is that the business critical database would become unavailable and then available again much faster than the general purpose database. And the reason for that is that the business critical database is just pointing to a secondary behind the scenes, whereas the general purpose database is looking for a node with spare capacity and then doing that failover. Now, again, it should be noted that both of these failovers, so you can see now we're back and connected, and both of these failovers happen within less than 30 seconds. What I found in my testing is a business critical one. Typically, a failover occurs between 2 and 6 seconds, so it's really fast. Today was probably one of the slower times. And on the left side with general purpose, this takes usually 20 to 30 seconds. So even in general purpose, it's still very fast and still with no configuration. So this is really the power of PaaS. And Bob and I were recording this a few weeks ago for something we'll share at the end. And at the end, Bob says, "That was awesome." And we have a clip of it. It's on Twitter. It's very fun. So this is just one example of the power of PaaS and how you can get really fast failovers with general purpose, but faster failovers with business critical. Now, the last service tier, which we're going to talk about today, which is only available in Managed Instance today, in Azure SQL Database today, is Hyperscale. Now, this is a very interesting architecture, but if we just start at the top, you'll notice you don't see the application and the gateways here, but it's the same thing here. So we're going to take care of the connectivity redirection. You're just going to connect to the logical server, and we're going to point you to either your read-write endpoint or your read-only endpoints. Now, as far as secondary replicas go, you can have 0 to 4. So as you might as you might think. If you have 0 secondary replicas, it's going to behave similar in a failover scenario to general purpose, where you have to look for spare capacity. Whereas if you have more than 1 secondary replica or 1 secondary replica, then it's a little bit faster for us to fail you over. And that automatic failover is going to happen the same way that it does in both business critical and general purpose. So if we take a look at this architecture just briefly, and we will point to more resources to learn more about this, what we have is we have a very interesting layering system, cache layering system, which we've basically re-architected SQL Server to run in Azure and to run at this big scale. And one of the big things that we did is we pulled the log service out. I'll move that down for now. We pulled the log service out, and this allows us to allow the log service to actually feed those replicas. So there's a lot more we could talk about related to this architecture, but just note some things like we're using a combination of Azure Premium Storage and Azure Standard Storage for the log service, as well as we're using snapshots, and that really allows us to do things really quickly, especially when it comes to size of data operations, no longer become size of data operations. So this is really interesting technology. Definitely recommend looking more into it. Now, if we just kind of compare the service tiers across the board, and remembering that hyperscale is today only available in SQL database, not managed instance, this is kind of how they compare of when you might choose one over the other. Well, a few things to notice is that you are getting all local storage really for your data, log, and TimTB files when it comes to business critical, so that can help with performance. This other thing is this IOPS thing, which you may not have seen before. It stands for IO per second, and I use this plus, 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 and no plus to kind of compare how you can get the best IOPS with business critical, but you can still get pretty good with hyperscale. It's going to depend on the workload that you're putting through it. So this is just an overview slide. Now, once you have a service tier, there are some ways you can kind of go to the next level. One of those ways is zone redundant configuration. You may have also heard this called availability zones or multi-AZ or AZs. These are all things to kind of symbolize the same thing. So I'm just going to move that down again. But what we're going to see is that this is currently only available in the business critical tier for Azure SQL Database. So just something to be aware of. But if you are in that tier and deployment option, it's free. It's very easy to set up. All you do is in Portal or the PowerShell, it's basically a switch which you turn on or off. Now, to give an example of what it is and why you might want it, let's consider we're dealing with a business critical database in the East US region. Now, with availability zones, what we're going to do is we're going to spread your replicas across 3 availability zones. And an availability zone is going to be something that's separable from the others. For example, these could be 3 separate data centers in the same region, but not the same building. And so this protects you if a whole data center goes down, you still have some replicas in other availability zones. So this is going to help you keep your availability high, even in the case of, pretty big disaster. And one of the wonderful things here is, again, you don't have to manage any of the connectivity redirection that's built in. We're leveraging Azure Traffic Manager, which then goes to the respective gateways and control rings and basically tells your application where to go. Now, many people ask us, okay, this is awesome. Why isn't it enabled by default? Now, the reason is if you have super chatty applications or latency sensitive OLTP type of applications, then this might introduce some additional latency. So you might want to be aware of that, and that's just why today we don't do it by default. But this is a really awesome technology, and what it allows us to do is give you a higher SLA or service level agreement. So let's talk briefly about the SLA for Azure SQL. What this is this is going to give you a guarantee from Microsoft, basically, and we'll give some sort of refund depending if we don't make this SLA, depending on your service tier and configuration. Now, there are a few things to call out here. The first is around hyperscale. We talked about how you can have 0 to 4 replicas and how that affects the rate at which you can fail over. You're going to see that in our SLA, which is what you see here, is that you get a higher SLA with 2 or more replicas. And that's just because it's kind of comparing general purpose to business critical in the way that we do a failover. Now, the other thing you'll notice is that, again, availability zones or multiple zones gives you a higher SLA. So that extra 5 you're going to get with a business critical database with 8 multi-AZs or availability zones enabled. Now, the other thing that I found really interesting, and Bob and I were talking about this morning, is that you think about 99.995% availability, or 4 nines and a 5, or 4.5 nines. What does that actually equate to? So Bob did the math, and he shared with me this morning that that's actually 26 minutes a year of downtime, which I think he worked out to like 4 seconds a day or something crazy like that. So it's really, really high availability guaranteed from our team. So that's really great. And we're the industry only solution that also has a business continuity SLA for the business critical service tier. So really powerful stuff. You just kind of get out the door based on your deployment option. Now, you could decide, okay, this is great, but I want to take it one step further. And perhaps I have a globally distributed application database, or I just want to have more read scale or other things like that. There are 2 options today in Azure SQL Database and Azure SQL Managed Instance. That's geo-replication and auto failover groups. Note that geo-replication is only in SQL Database today. And there are some things, pros and cons to each of these. That's why I kind of made this chart, because in my opinion, the blue represents things that are better in one thing versus another, or reasons you might consider one versus another. So to give a few examples, auto failover groups can do, as the name suggests, an automatic failover. Now, you're not going to get that with geo-replication. And when you have an automatic failover, since you're just connecting to a failover group, you don't actually connect to a logical server or an instance, we can take care of that redirection, similar to how you saw in the other service tier. So if a failover needs to happen, you can stay up and running, we'll fail you over. You don't need to change anything in your application to still be able to connect. Now, some benefits to geo-replication is that you can have multiple replicas. So if you really want read scale, you want this in 5 or 6 regions globally, geo-replication is going to be the best option, because today you can currently only have, one failover server in auto failover groups. But both of these options are going to give you read scale. So all this being said, great options for getting global scale with Azure SQL Database and Azure SQL Managed Instance. You just need to think what's going to be the most appropriate for your scenario. The last thing, or one of the last things you want to talk about when we talk about availability, is availability and consistency. Now, a few things to consider that I think many of you will be aware of is that things like dedicated admin connections are allowed. For example, if you get hung or some situation like that. Accelerated database recovery, which in this deck, which we'll share out, there's a very interesting paper that talks about how this works, is on by default, and you actually can't turn this off. This helps us to meet our SLA. Now, when it comes to consistency, right off the bat, I think it's important to just call out again that you have multiple copies of your data and log files and your backups. So you have a lot of redundancy just going out the door. Additionally, we do things like backup and restore integrity checks. So for example, every now and then we run an automated restore test of your backups. And we can also do things like we have checksum on by default. And if there's any sort of issue, we will repair it without any notification to you if there's no impact to you. So we kind of take a lot of that responsibility. And if there is some sort of issue, then we definitely get you involved. We get you involved in touch with engineering, and we make sure we work through it together. So there's a lot of stuff here. Also, you should note that you can run dbcc checkdb, but with no repair. And so there's a lot here, a lot of great ways where we're keeping you available, we're keeping you with good backups and consistent backups. Now, once you know all the options, the thing you really need to decide for your scenario and for each scenario that you have is really, what do you need? What's going to be the best configuration for keeping you at the availability SLA that you require? And a few of these questions make sense, but one thing we really like to stress is that last question. Is your application ready? Now, there are a few things you need to do to make sure your application is ready to, for example, if you have groups, do you also have a secondary application running in that same secondary region so that if you fail over, your app and database can stay next to each other? We talked about retry logic as well, and there are some slightly different errors that come when you cannot connect to your database in Azure SQL. So you really want to make sure you're following the retry logic guidelines in our documentation. So a lot of things around making the right choices, but really a lot of the hard work or the heavy lifting is done by the Azure SQL service itself. So if I just try to summarize some of the things we talked about automated backups, how you get geo restore, you get long-term retention up to 10 years, and you can get point-in-time restore. We also talked about some of the really powerful built-in high availability architectures behind the scenes that really power a lot of the availability of your database without you having to do anything except make that choice. We talked about the SLA and how you can go further with availability zones or auto failover groups or geo replications. And also we didn't touch a ton on it today around monitoring, but we will share resources in this deck on more on that. And so now that we've kind of talked about availability, the next reasonable jump is to talk about performance. How can you get the best performance given whatever availability model or service tier that you've set up, and how is this different from what you've seen in SQL Server? So that I'm going to pass it over to Bob to talk about performance.
Thanks, Anna. The built-in availability story for Azure SQL continues to amaze me. I've been in SQL Server for so long. The fact that we do so many things for you behind the scenes is a great promise of something to do in the cloud. But certainly as a SQL Server professional, you want to make sure your application and query are performant. And you want to be comfortable that you have all the stuff you're used to doing in SQL Server, whether it's configuring or monitoring or capabilities. I want to make sure I have what I need. And I also want to know, is there anything different here? Is there any promise of the cloud, kind of like availability, that I get by going to performance? So one way to attack and look at performance is from the perspective of capabilities and tasks, because this is the kind of stuff you do. You want to make sure you have the right capabilities for performance from your SQL Server in the cloud, and you want to make sure that the tasks you normally do to configure and monitor and keep your application fast and queries fast are available to you. All the familiar stuff and things you need maybe perhaps in the cloud that are kind of different. So let's first talk about capabilities. First of all, you need to be aware that this is SQL Server. So in the SQL Server engine, all the stuff you're used to is going to be there, right? Things like column store indexes are in Azure SQL just like they are in SQL Server. But first, think about capacities. Today, when you have to do capacity planning in your environment for virtual machines or bare metal, you have to know what's possible. And Anna already introduced you to the concept of service tiers and talked about managed instance and databases. So take a look at this screen and kind of see today, this is the maximum capacities that you get when you choose one of these options. Consider the fact that with Azure SQL Database, you can get up to 128 vCores, certainly a large amount of memory, more than you probably expected, and a large database size. But hyperscale, you can go all the way to 100 terabytes. Now, managed instance is going to have slightly different types of limits and capacities today because you're getting an entire virtual cluster with this instance. I expect that every quarter I have to change this slide because we continue to push the limits behind the infrastructure of Azure of the max capacities we can give you. When it comes to indexes, which are important to SQL Server query performance, everything there is there you need, including online resumable indexes and column store indexes, which are available in almost all the tiers you have for Azure SQL. Now, incremental TP, which is a low latency application scenario that we have built, a capability of SQL Server that started in SQL 14, it's there. but we've kind of reserved it for business critical tiers. So just keep in mind that if you want to go down this path, you'll need the business critical tier. And just like in SQL Server, we'll apportion a certain amount of the max memory limit we give you to limits for in-memory OLTP. But there's some other capabilities to consider as well. Maybe you've used partitions, and we support that concept. Now, you're not going to use partitions for I/O placement. You can do file group placement on managed instance, but the idea of doing partitioning is going to be available for you in Azure SQL. You may have heard me on this very user group last year talk about SQL 19, and most of the enhancements that we put in performance for SQL 19 are there in Azure today. Things like intelligent query processing, for example, is something that first actually started in the cloud. So this is an example of us trying to make sure we tie together what you're used to in SQL Server with what you're used to doing in Azure SQL. So if you keep thinking about what's involved in making your SQL deployment fast and keeping it fast, certainly configuration is a concept for you, right? That you got to think about. And nothing starts a conversation about performance for configuration than TempDB. Everybody wants to know, how does TempDB work? Now, just like SQL Server, we are going to do some configuration things for you so you don't have to worry about it. Number one, out of the gate, we're going to put TempDB on SSD drive. So don't even worry about I/O performance. We just have that figured out for you. But in Azure Database and Managed Instance, we are going to pre-configure the number of files and capacities on sizes for you based on your deployment choices. Now, you could probably have some questions here. You're like, hey, do I need more of these things? In my testing and consideration for performance, I have felt that the number of cores you get and the managed instance deployment you get, that we have provided the proper number of files for you to avoid latch allocation contention problems. TempDB metadata optimization is something in SQL 19 that we would like to bring into the cloud, so it's not supported today, but it's something we're actively working on. You also find yourself configuring your database and all the different options you get for alter database scope configuration, all that stuff exists for you. But one thing worth calling out is recovery model for your database. You're used to actually perhaps using a minimal recovery model for your database for bulk loading operations. So just keep in mind the fact that we have to have full recovery model for configuring databases, and that's something we require for our SLAs. Yeah, so if you're thinking about bulk operations, it's something for you to keep in mind that you need to make sure that you don't get a minimal recovery model. You have to use a full recovery model for SLAs, but TempDB is available for you to do minimal logging. Now, you might consider doing file and file group configuration in your environment for I/O performance. Here's an important point for you. We do not allow you to physically place your files in Azure SQL. This is a managed instance or in database. Virtual machine, of course, you would do that. But here's the good news. You don't care. We have resource capacity commitments that we make from an I/O perspective, depending on your deployment options. So you are abstract of that for a very good reason. We don't allow you to do that, but you don't care about doing that. There are reasons, though, you might want to consider configuring the number of files and the size of files. And we support that more in a managed instance environment where you do more file management. And you actually can boost your I/O performance by just making those kind of tight configuration scenarios. But there are other things also to consider for configuring performance. And one of those is max DOP. Who doesn't ever consider max degree of parallelism? Well, guess what? Everything you have available today for max DOP is there for you in Azure SQL, whether it's altered database scope configuration, using SP-configure, query hints, or even in the case of managed instance, to change max DOP settings for resource groups, for resource governor. And in fact, speaking of resource governor, you do get the ability to do user-defined workload and groups for resource governor in managed instance. It's not a concept that you do at Azure SQL Database. We do that automatically behind the scenes to do some of our governance, but you do have that ability in managed instance. Now, anybody on this phone here has used DMVs and extended events, and you're like, do I get that stuff? You get that stuff. We'll talk about DMVs a little more detail in a second. But note that in your environment today, in your data center, there's some monitoring that goes on outside of SQL. Well, as the Azure ecosystem has capabilities like Azure Monitor, where we'll integrate metrics, kind of like a Windows Performance Monitor, because you don't have access to run that, but we have Azure Monitor, which is inside the Azure ecosystem and infrastructure. We'll tie into that So things like the Azure portal, you can do alerting, you can do logs, and do metric views, do graphs, just like you can do in Windows Performance Monitor. We're going to tie into that environment with our Azure SQL deployments. Lightweight query profiling or query plan debugging. These are things you're used to doing in SQL Server. They just work. All that stuff just works as is with Azure SQL. It's going to feel very much like in your SQL Server environment today. And we're certainly going to look at Query Store in a second. Query Store is on by default. It's a very powerful capability that is with SQL Server, started in SQL 16. We support that today. And in fact, we will light up certain performance visualizations and capabilities based on Query Store. Now, speaking of DMVs, a lot of people want to know more about the details of dynamic management views, because it's one of the core things you do with your SQL Server environment. And the good news for you is that an Azure SQL managed instance and an Azure database, we have all the DMVs you need. Most of the common DMVs that you're there in Azure SQL database, and all of them there for managed instance. But note here on this slide, there are some DMVs that are new to Azure. And we provide those for very good reasons. And I'm going to show you an example and a demonstration in a second why I think it's important that you know about those. Now, there's some other DMVs you need to know about that you've used in SQL Server that are important in Azure SQL. One of those is DM/IO virtual file stats. You don't have access, again, behind the scenes to like what's going on the host or the virtual machine for IO. So if you want to look at things like IO latency, you're going to use a DMV like DM/IO virtual file stats. And DM user DB governance is a very interesting DMV. This is a way from you, from a T-SQL perspective, to see that deployment service tier that Anna talked about. Because when you do a deployment service tier, it's going to affect those capacities I talked about. How much memory they get, how many CPUs to get. You're going to want a way to detect from a programming point of view what that looks like, and that's the kind of DMV that we'll light up for you to be able to do that. Now, you undoubtedly want to geek out. A lot of people want to see internals. So we do actually have some pretty deep DMVs, and we expose these. We don't fully document all these kind of things, but we expose these, and these are things that we use behind the scenes to do deep debugging of performance in your environment. So I was talking to Anna about performance when we were building out content for Azure SQL. And one of the things she asked me, says, Bob, you've been doing SQL Server for a long time, especially performance. How do you attack a SQL performance problem? And I said, I was in support for many years. So one of the things we did a long time ago was ensure that we could break down a performance problem into these two areas, running or waiting. Kind of a divide and conquer approach. So I wanted you to see the perspective of running versus waiting, because it applies to SQL Server and Azure SQL, and kind of show you some of the resources you might use for Azure SQL to attack this. You're going to first look at resource consumption. You're going to look at things like Azure Monitor, which we'll show you in a second, or you can look at DMVs to see what that looks like. If it's a running problem, which is like high CPU, you are going to look at these kind of type things. You look at Query Store, a DM exec request. Who hasn't used that one before? You might look at things like SOS scheduler yield weights for CPU capacity. It could be a waiting problem. It could be you're waiting on a resource. And these are some of the scenarios you may have seen. Maybe it's a common blocking problem. Maybe you're waiting on a latch. Maybe you're waiting on IO. And you're going to use common DMVs that you've used before, just like you're going to do in SQL Server. You're going to have those, access those in Azure SQL, or even something like Query Store. Now, because you're running Azure SQL, there are some scenarios, mostly around waiting, that I think you should know about that are specific to Azure. First of one of those is called log governance. In order for us to meet SLAs that we've promised you, we have algorithms in the engine to throttle or limit the amount of transaction log traffic that you might generate from your deployment. And based on your service tier and deployment options, we will up that governance of what that looks like. If you end up hitting one of those throttles or rates, these are the kind of weight types you might see in common DMVs for Azure SQL. Now, in addition, you might look at worker limits like max worker threads. You're probably used to seeing that. And in Azure SQL database, because we're abstracting you from the instance, we have errors that might pop up because of concurrent worker limits, and we document what those limits look like. So this is an example of an error scenario your app needs to be able to handle in case you run out of workers. But in managed instance, at least today, we support the common max worker thread scenario. So thread pool weights might be something you see, although that might change in the future. We still may scale that, but today it's all based on max worker threads, just like a SQL instance. Now, one of the interesting parts about Anna's presentation on business critical is the fact that we're using availability groups. So I know when I first talked to her about this, I said, Anna, by the way, don't be surprised if you see header sync commit waits. She's like, well, why am I going to see that? I didn't deploy an availability group. You're like, yes, you did. You picked business critical, so we deployed one on your behalf. So you might start monitoring wait stats or DMVs, and these wait types pop up, but you didn't expect it. So these aren't new to Azure SQL, but because you picked business critical, it's something that might show up. In addition, Anna showed you hyperscale, the unique architecture of caching and page servers. So we have log governance there as well, and there's different weights that may show up because of the fact you're being governed from a perspective of using hyperscale, because we have to make sure that we can keep that log service up to date to keep your replicas and page servers up to date. And IO statistics may show up in some different ways. A page read from a page server may show up in DMV slightly different. And so we've augmented and enhanced our diagnostics to make sure you can see those kind of situations for doing performance analysis of hyperscale deployments. Now, it's very possible that as you go through this exercise, just like a SQL server, you want to make things faster. So what if you run out of CPUs and you look at that running or waiting scenario? What are you going to do? Well, guess what? Without any database migration, you're going to find you can scale CPU capacity both up and down. And in fact, with serverless, we can auto scale. So there might be some small downtime, and Anna showed you scenarios for business critical and general purpose where there can be some downtimes, right? She showed how fast that can be. But the fact is, you can scale CPU capacity without any deployment on your side. In your environment today, what are you going to do? You might have to change your VM configuration, or what if you run out of logical CPUs on that host? You have to move your database to the bare metal server. That's not required in Azure. IO is certainly something that's certainly very important to you. And so knowing your IOPS restrictions from your application can be important. It could show up as longer IO waits. And based on your deployment options, both in managed instance and database, both IOPS and IO latencies can be affected by your choices. Quite frankly, the higher vCores you go, the higher tier you pick, the lower latency you get. Remember, business critical is using local storage. So of course your latencies are going to be faster than they might be in a general purpose, which is using shared storage. And don't forget about multi-statement transactions. I have customers that will take a singleton transaction scenario, run it on their SSD in their laptop, put it on a general purpose Azure and say, hey, you're not as fast as my laptop in the cloud. And I'm like, yeah, but did you put all that built-in availability on your laptop behind it? So keep that in mind that in some cases, going to a more efficient way of doing multi-statement transactions can be your solution versus kind of scaling up from a service tier perspective. There are other considerations like memory and workers. We talked a little bit about workers. Memory is something interesting. Memory is something we are going to limit for you, just like you would limit in your VM or your bare metal server environment. We're going to do that based on your vCore choices and based on your service tier choices. So check out our documentation. We have tables to describe what are the memory capacities. And think about a SQL server. That's going to be your upper limit of your memory, just like the upper limit of your virtual machine memory. And then we're going to use the standard max server memory algorithms underneath that. And finally, Anna talked more about applications being important in terms of retries. What about latency? So one thing that we didn't really get to dive into today, but you can look up and read in our content, is using redirect connections instead of proxies to get much faster application latencies. And just consider about chatty applications. We have customers that'll move to the cloud, and all of a sudden they realize their app is slower. That's because they're not taking advantage of server-side programming using stored procedures or doing things like batching or multi-statement transactions. So we have found customers that have discovered by moving to the cloud that they are not being very efficient in database applications. And so keep that in mind when you're thinking about application latency scenarios. Now, if you think about this entire diagram right here and look at all the different things I pointed out, what's missing? Well, it's still SQL Server. So making sure you have the right indexes, although we're going to talk about a solution here before we're done that can help you, or batching or procedures or parameterization or processing results, tune your SQL queries just like it would be a SQL Server, and you'll still benefit because it is still the SQL Server engine running behind the scenes. Now, let's go take a look at a demonstration. Enough of slideware here. So let me change over here myself. And Anna, can you just kind of verify you can see my screen?
Yep.
Perfect. So looks familiar maybe to you here. This is a virtual machine running on Azure, and I am going to kick off a SQL workload, and I'm going to talk about it. So from the command line. As a lot of you've seen me before, I'm kind of a command line kind of guy. So I'm going to run O stress, by the way, behind the scenes, which Anna showed you for availability. I'm going to kick off a workload. Now I'm going to run some stuff that's familiar to you. I'm using Management Studio. I'm connected to an Azure database. I'm going to run DM exec requests. And what am I going to see? I'm going to see in this scenario a lot of runnable queries here, right? And SOS schedule yield weights. That's something that shows up really quickly with this workload. I'm going to use a new DMV that I talked about that's new to Azure to show you what is your overall resource usage. Remember the running versus waiting scenario? Well, this is going to help you look at running versus waiting. You notice here, I'm using a lot of CPU utilization running this workload. And you might want to see like, well, what is the workload doing? Like what is happening here? Well, in this right here, I'm going to show you, here is the workload. It's using O-stress. Here's my logical server. I'm running this query. I'm logged in with this SQL admin account. I'm running 10 concurrent users iterating twice, just running this SQL script. Well, what's that SQL script look like? So if you look over here, let me pull that up. I'll show you. It's really not that sophisticated. It's an aggregation that I'm running against AdventureWorks, a simple little sample. Now I'm running it in a loop because it might be simulating a query that's run very often in your environment. And then just to show you that I'm maximizing CPU resources, I'm actually assigning the value to a variable. So I'm really not even returning many result sets from running this application. Let me go back over here and kind of just poke on this and see. It looks like it's actually done. In fact, if I run this DMV, which by the way, we poll your resource usage every 15 seconds, you can kind of see that it's kind of winding down and almost finished. In fact, if I go back here, I can tell that this is finished in about 1 minute and 30 seconds. Now, how do you know if that's slow or fast? Let's go take a look at a few things. Let's go look at the query store. These are reports you used to be using in your SQL Server environment. If I look at the top resource performing queries, I can see already from this plan right here, I can tell that I'm running an average duration of only 4 milliseconds. Well, is that bad? Well, look at query weight statistics. You can see the highest weight type is CPU, which is kind of like a running scenario. And in fact, if I click here, I can see for my query, the average wait time in this is almost the entire duration of the query. Well, that's not good. So how can we make this faster? So let's just do this. Let's go over here. And the first thing I'll do is I want to flush the query store because I'm going to do a scaling operation. I'm going to show you in using T-SQL. This is the part that's interesting. I'm going to use alter database to go to 8 processors. And you're saying to yourself, you're going to do what? How do you use alter database? We've infused T-SQL to understand Azure and understand how to change things like scaling so you can actually scale up using just T-SQL. And I'm going to go over here, though, and run this query to see what does this operation look like. And, oh, I've got to run this in master, logical master. In fact, what I'll do here is I'll go here to the system database one, to logical master in my logical server, and I'll see what that looks like. So I'll run this here. And this is a way how we're going to be able to look at operations like scaling, and you can see it's already finished. So now I'm running 8 CPUs. Let me go back and run the workload again and see what happens. So let's kick it off. Let's go back over and take a look at our DMVs. So first of all, let's look at DM exec requests. I can see here that I do have some runnable, but notice there are far more running queries in this scenario than before. And if I go look at our resource usage here, let's go over and look at that. I can tell here, oh, look at that. It's kind of reduced significantly from before. In fact, if I flip over here, you're going to see in a very quick time frame that this query is going to finish significantly faster. And you might be asking yourself, like, why did this finish faster? Well, remember, I had SOS schedule yield weights, right? That was the primary weight that I had. Well, I've given it more CPUs, so effectively, I had a CPU bottleneck workload, and now I'm running it significantly faster. And Query Store can show you that. So I can look at top, notice the difference in the 2 queries here. It's the same query, but I had to get recompiled, so it's significantly faster. And if you look at query weight statistics, you can see I'm still CPU is the highest weight, but the average wait time for this new query here is super, super fast compared to what was before. In fact, the average wait time is only 0.41 milliseconds of the overall execution of the query. I can even flip over to the portal for Azure, and notice here the compute utilization is showing the Azure metrics I mentioned before. This is us integrating with the Azure ecosystem to show you a visualization. I even have the ability, if I want to go down here and look at logs to run something called Custo queries, where I can see what is going on with performance. And this is going to give you graphs to show you performance over time. You're going to get a history of a long period of time, several months, to go back and look at performance information. So let me stop sharing my screen. And Anna, I'll let you go back and bring the deck back up. Okay, so we are very much running out of time here, and I want to make sure I give us some time, just a few minutes for a few questions here. So I just want to kind of wrap up and tell you that there are bigger reasons to go to the cloud. Intelligent query processing, automatic plan correction. This is functionality that exists in SQL Server and in Azure to make you faster with no code changes. But automatic tuning is interesting. It's unique to the cloud. And it's unique in the sense that what we do for Azure SQL Database is we will actually offer you the ability to do automatic indexing. We will use the power of the query store and machine learning algorithms to help recommend, and even in some cases, automatically create indexes for you. And if you go back and look at our deck, if you look at the content that Anna's going to talk about here at the very end here, we have demonstrations to show you what it can actually look like in your environment. This is a screenshot of showing you visualizations in the portal and recommendations that you can get, all about doing the right thing with machine learning algorithms, using query store and DMVs to recommend indexes for you. So kind of just wrap it up real quick here in a summarization. Azure SQL has the performance you need. We have the capacities you need. We have the tools you need. We have everything that SQL Server gives you and more, because you're running in the cloud. And if you think about these two topics combined together, Anna, I think it just gives everybody a feeling that this is SQL Server, but we're doing many built-in capabilities to keep you available and to keep you fast.
Yeah, definitely, Bob. And thanks for that deep dive on the performance capabilities. You know, as we wrap up, before we get to a few questions, I did want to share a few resources. Actually, this is exciting news because tomorrow we are launching a bunch of things on Microsoft Learn, on YouTube, lots of content similar to this, except going much deeper and over longer periods of time. So definitely follow us on Twitter and check for the updates on where the stuff we launch actually lands tomorrow. It's going to be really exciting. And then if you want this deck, I've gone ahead and put it in my GitHub site. So that's just the link to my GitHub. And if you look for the perf and availability section, you can find it. And I'll leave this up. But we really want to thank you all for having us, and we will take a few questions.
Brilliant. Thanks so much, Anna and Bob. We've got actually quite a wide range of questions. I kind of jump from topic to topic through each of your decks. So I'm just going to go in reverse order, and hopefully that'll be okay. So we have a question here: is when you start to see rate limiting weights, how do you evaluate whether those weights are impacting enough to justify a high performance subscription?
Yeah, that's a great question. So if you look at the scenario I showed you, obviously it was a CPU limiting scenario. Like, we just ran out of CPUs. SOS schedule yield weights are common even to see in SQL Server to measure that. Now, it could be that you could tune the query plan. Maybe you're just using too much CPU because of an inefficient plan. But in my particular case, I didn't have that. So that's why I need to know if I need to scale CPUs. But in the content that Anna has talked about that you're going to get starting tomorrow in our launch, I have another scenario where I run into write log weights. And you could get better performance by going to a new service tier, but you also could tune the application to use multi-statement transactions to avoid those weights, or at least make those weights a lot less. So it all depends on the weight scenario, and it all depends on what you've deployed and whether there's a chance to tune your app or make a change in your service tier deployment.
Brilliant, perfect. There's a question on, will managed instances support on-premises always on as a replica option?
Yeah, so managed instance, of course, today is a cloud offering. And today, if you want to do a secondary replica for an on-premises availability group, you can do that in Azure Virtual Machine. We've talked about how to extend on-premises scenarios into managed instance type things. That's actually something we're taking a look at. I can't promise you that we'll use that specific scenario, but it is something we're thinking about. How do we take advantage of that managed instance and not just be only in the cloud and only allow availability groups as replicas in a VM? So it is something we've thought about. I can't make any promises on any kind of roadmap or anything we're doing right now, but it is a consideration of something we talked about in the team.
There is a general question as well about where can we get the recording of this video, and can we get the deck slides? The deck Anna has thankfully left up on the screen, so you can get that there. There's a quick question on, will the documentation that is listed here, will that include pricing information, or would you have to go somewhere else to get that?
Yeah, that's a great question. I can take that one. We do generally give guidance on what's more expensive and what's less expensive, but for the actual exact pricing, your best bet is to look for the Azure pricing calculator. That's going to give you the best way of kind of understanding that. There's also a tool called the Data Migration Assessment Tool, DMA, and in it has a script you can run called the SKU recommender, and it can actually recommend a service tier and give you a pricing estimate there as well. So two kind of options, one's more technical and one's more just easy to go find, the Azure pricing calculator.
Brilliant, thank you. So you mentioned as well that there is multi-region support for Azure SQL. There's a question here, is there any option for an active support, or is it read write one and a couple of read-onlys as well?
Sure. There's no there's no current plans as it stands today that I can talk about regarding that. It is something we've been looking at, just thinking if that's the right direction to go. So if that is something that whoever asked that question has feedback or insights on, I'm guessing they're just comparing it to like Cosmos DB, then you can reach out to me on Twitter. You can send me a message. We can talk more.
Perfect, thank you. The metrics that you defined, especially the new ones, the resource DB ones, people are actually clamoring for that. So how would they get to know more about these different DMVs? Do you have a
thanks for asking that.
link?
It's all documented. So you can get this deck. You can look at the names of the DMVs. We have complete T-SQL reference for it. You can look at, and what Anna's just talked about, we have amazing labs. You can go through and try them out yourself, but all the columns are defined. Everything you see in there is defined in our documentation.
Brilliant, that's amazing. And again, like you said, the labs are something that I'm definitely gonna be looking forward to myself.
Yeah, this is a huge launch, folks. I'm telling you, wait till tomorrow. You're not going to believe what we're launching. This is a cumulative set of work that the two of us have been involved in, a bunch of others for like the last 7 months. So I think you're going to be blown away with what you're going to see tomorrow.
Perfect. And the last one is, someone just wants to double check that you mentioned that we don't have to do patching in Azure SQL.
Yeah,
yes,
I'll take that.
So, yeah, go ahead.
I'm sorry. Yeah, we just have this concept called versionless SQL. So you don't worry about a version, you don't worry about those kind of things. We handle all those scenarios of continuously updating, not only just a SQL Server in the background, but the operating system, the VM, all those kind of things. So yeah, that's one of the promises actually of Azure.
Great. I've been told if they answer yes to say thank you. So thank you.
Thank you, folks.
I believe that's it. The rest are kind of variations of the same question, but you've answered all the questions I have for you so far. Thank you so much for the webinar.
Thanks everybody on the user group, and thanks Shane, Steve, everybody for hosting us. We appreciate it.
Yeah, and that's it. I just want to thank you both, Anna and Bob, again for a great presentation. And for everyone who is still currently watching the webinar, the 18th, we have Andy Yoon doing Beginner's Guide to Performance Tuning. We will try and get the recording up as soon as we can, and please go check out those labs and documentation that was shared today. Thanks again, everyone.